Yeah, it is recording. Okay, so this is the announcement I sent this morning. Please make sure that you are receiving all the announcements that I'm sending. That's important because there you will receive all the information. I will try to send you an announcement at least once per week, but I believe I'm going to be sending like 1 or 2 at least announcement per week, so you will receive updates from the class. The other thing that I want to share before we start is that now our Blackboard page is ready. So now I already organized everything, so it is easier to navigate. So here you can investigate what's happening here, but just to quick review, announcement is the first page, or state orientation start. Here is where you are going to see my contact information, something very simple. And this document that I prepared for you, this is a navigation guide through Blackboard. So just in case you have doubt where the stuff is, you can go to this document and know the meaning of each button on Blackboard. This is desktop version. I haven't worked on the cell phone version, so if you're using your cell phone, it might look a little bit different, but the content is going to be the same. Okay. Course information. So I changed syllabus and calendar to course information to be more generic. So you are going to be more. You're going to see that we use more course information instead of syllabus and calendar across the community college. So I prefer to change to course information so it is easier to understand and to follow. Syllabus and calendar are still there, are the same. So then you will see that I changed it to our classroom. In our classroom, I pull all the folders, educational folders, where you are going to get the draft, when you are going to see the reviews, and the practice, the test, the quiz, and the final project. So all those folders are in our classroom button. So that way, the only thing that you need to think is clicking on our classroom, and then you are going to get the material. YouTube is, when you enter to YouTube, that is the link to the channel that I'm going to be posting the lectures. So right now there's nothing there, but this afternoon I'm going to start posting, uploading the videos, this one, and then you are going to see it there. Tests and quizzes is just a shortcut to the folder that is in our classroom, tests and quizzes, because here is where you are going to be submitting your tests and quizzes. Okay, so that shortcut is going to make things a little easier if you just want to submit the test or the quiz. My grades, I haven't create the entire gradebook on Blackboard. That is something that I'm going to finish for next week. But as soon as I start putting everything, or the assessment or the grades on Blackboard, you are going to click on my grades, and then you are going to see your own grade. Zoom meeting. So if you click there, it's going to take you to our Zoom virtual room. So that's just a link that gets you directly to the Zoom of our class. Today, the review of the class for test number 1 is available. So if you go to our classroom, click on reviews and practice, you are going to see 2 files there. The first one is the study guide for test number 1, and there's a typo there. I'm going to change that later. Don't worry about that. But what is most important is 1148 review test number 1. As you see, it has a due date. And what is the meaning of that due date? Let me transition to our calendar for a moment. So here is our calendar. So we already finished lecture number 1. We are on lecture number 2. On the 15th of this month, you see here, review test number 1. That means that the due date for the review of test number 1 is on the 15th of this month. The review has 20 pages, and I try to put all the exercises that you will need to get ready for our first test. Okay, if you want more exercises, just let me know. I know that Jordan and Nicole, you request more exercises. I'm going to post more exercises on the weekend. But I believe the review is going to be enough for getting ready to the test. Okay, we are going to start working with the review since today. So by the time of the 15th, you are going to have your review completed. The review and the practice, they are going to be together. So you are going to earn credits for the review. Once you take the practice test, you need to take the practice test first. Then on the 15th, you need to submit your review on time, complete it, and then you are going to receive the credits. The credit for the review are going to be based on completion, not on accuracy. You are going to make sure that everything is correct, because since today we are going to start working with the review. Okay, but what I want to see on the 15th is that you completed the review, that you have worked all the exercises, and that's the only thing that I want to see. Okay, because at least for me, that is going to tell me that you are ready for test number 1. Is that true or not? That's up to you. It's your responsibility. I am giving you the opportunity to finish the review. I will going to grade it by completion. Okay, you will see that the review is going to be just 25 points in combination between practice and review. There's not much points there. The purpose of that is to getting ready for test number 1, right? So don't worry, the review is long, but we are going to be working on it, all right? So yeah, you are going to submit the review here, and to work on the format on the review, I prefer you to print it out and then work on the review on paper and pencil, or if you have a tablet or an iPad, you can work on it, or if you have a stylus like me, you can work on it digitally. But I don't want to receive like loose papers with just the answer. I just want to follow the review there. So preferably it would be print it out, complete the review, and paper and pencil, then scan it and then submit it back here. If you need assistance with that technical stuff, let me know and we can meet after class to see what is the better option for you. All right. Okay. Salma, and I have other videos from other classes, the College Algebra Plus. Maybe I can make those available for you, but the topics are not necessarily aligned, okay, with the class that I'm going to be teaching this summer. So I'm going to do that. I'm going to post those past videos of me working on other topics, but they are not necessarily aligned with what I'm going to teach this semester. All right, any question? Yeah, I can hear you. Unfortunately, I'm still waiting for a response. Yeah, I will try to reach out again on Monday, because that's something, if you pay, that's something that you need to have access. I would try, I hope to set everything on for next week. Yeah. All right. So you had read the first 20 pages of our draft, and our draft is here. Okay, you will see that the first 20 pages is more definitions, or more I just presenting things that we need to know, like for example, how to write interval notation, how to distinguish between set notation, how to use the parentheses or the square brackets. If you still have questions about this, just trust me and ask question. I make your question. All right. This is something that I am assuming that you understand, but if not, that's okay. We can go back and review it. Okay. So yeah, those are the first 20 pages. I'm scrolling down here quickly because I want to get to page number 20. Where are you? Okay. 20, 21. Okay. So any question? 18, you have 18? Yeah, mine it says 20, but it's 18. So 20, you should at least read the first page of the library of parent function. Did you see this page? If you read the first 20 pages, you should have read at least this first table. Okay. Library of parent function. If you haven't read it, that's okay. Library of parent function. It is important. It is important table because I made a table of this that we are going to use across the entire semester. I'm not asking you to memorize every detail of this table. I'm asking you to know that this is going to be important because our work is going to be based on functions. And the library of parent function is going to give us those basics properties of the different functions that we are going to be studying on that are going to be very important for our analyzing different scenarios and situations. Okay, so I'm not asking you to memorize this completely, but I am asking you to know how to use this, and I'm going to present to you example where we are going to get back to here and to analyze what we have in this library of parent function and to apply them to the different exercises. Okay, so yeah, that's what I wanted to talk about, this, the library of parent function. We are going to get back to this just in a moment. All right, so as a review, I want to go and talk about a few topics that are important. Let me move to the review. All right, so you have the review. I'm not sure you have downloaded it already, or you have it ready on your computer, or you have printed it out already. Okay, but our review is what we are going to use for the exercises that I'm going to present on class, the example that I'm going to use, and the question that you might have. You go to the review, you have a question, please elaborate that question and present or ask that question, make that question during class. Okay, this is something that I want to be more dynamic rather than just me selecting the exercises to present in class. I want you to go over the review, and if you got stuck on a specific exercise, mark it, bring it to class so we can work on that question. Okay. On the review, what I want to talk, or the first topic that I want to review, is how to test for symmetry algebraically. Okay. So symmetry means we have three types of symmetry when we are working with graph. We have the symmetry across the x-axis, the symmetry across the y-axis, or the symmetry across the origin. If you have doubts or question about what is or how a symmetry looks like, you go to the graph, identify that topic on the graph, and then look at the examples that I put on the draft. This, what we are seeing here, is a graph that has symmetry with respect to the x-axis. What does that mean? Well, that we have like a mirror effect between the top part of the Cartesian plane and the bottom part of the Cartesian plane. Let me erase this because this is going to confuse you. Okay, so what we have here in red is the same but reflected in blue. Y-axis symmetry is the same concept, but is with respect to the y-axis. So we have here on the left side in blue is the same that we have here on the right side in red. With respect to the origin, it's a little bit more tricky, but there is a diagonal here. Okay, this diagonal here is making the mirror effect between the left side of the graph and the right side of the graph. But see that we have, when we are talking about the origin, there is a reflection. There are two reflections. The first one is across one of the axes. For example, if I take this, let me see if I can rotate this. Can I rotate this? Rotate 90 degrees. That doesn't look good. So the thing is that what I have here on the left side is going to be reflected on the right side. Let me see. Yeah, this software is not too good for rotation, so that's, I only have like, let me see if I can flip it just vertically and then flip it horizontally. Yeah, okay, there it is. Thank you, Timothy. Okay, so with respect to the origin, what we are going to do is to reflect it across one axis first and then across the other axis. Okay, so that is the mirror effect. You are going to start like recognizing those effects with the most as we start like looking at different graphs and studying those graphics, you are going to start like picking up those effects. They are not too important in our class. It's just something that you need to know. What is most important for our class is to know how to determine symmetry algebraically. So, and that's why I want to stop for a moment, because at least I want to present to you an exercise. And the exercise that I'm going to do is this one that we have here. Okay, so what are we going to do here? We are going to test symmetry of this equation, the symmetry of this equation algebraically. So we are not going to see its graph to determine symmetry. We are going to do the algebraic test that we have for symmetry to determine what kind of symmetry that graph has, or that equation has. Okay. And this is what I want you to do on the test. So I'm going to ask you, the instruction I'm going to tell you, test for symmetry for all the type of symmetry. For symmetry with respect to the x-axis, symmetry with respect to the y-axis, and symmetry with respect to the origin. So what you are going to do is first, let's start with symmetry with respect to the x-axis. So we are going to test the symmetry with respect to the x-axis of this equation, of this graph. What are you going to do in order to test the symmetry with respect to the x-axis of this equation? If you are testing for the x-axis, what you are going to do is to replace the variable y with minus y. That negative in there, what it is saying that we are going to replace the variable y with its opposite value. Okay? The effect of that negative in front of the variable y is telling us its opposite value. So that's what we are going to do. I'm going to take the variable y from the equation and I'm just going to replace it with its opposite value. Okay, once I've done that, what I want to do is to simplify the equation that I have here. Why do I want to simplify? Because I want to compare what I have after the replacement. I want to compare what I have, the resulting equation after the replacement with the original equation. The original equation is the one that it is given in the exercise. We are going to compare our result with y equals 16 minus x squared. If they are equal at the end, then that means that the test is successful. Therefore, there is a symmetry with respect to the axis that we are testing for. All right. Here we are testing for the x-axis with respect to the x-axis. So since there's nothing surrounding this variable here, this negative y, we can erase or we can drop the parentheses. And that's the only simplification that we need to do. After that, what we want to do, so we finish with the simplification, there's nothing more to do. So let's just compare our result with the original equation. Is it the same? Do we have the same here as in the result as in the original equation? Let me know in the chat or just unmute yourself and tell me if we have if these two equations are the same or not. Are you seeing this well? How is this in your end? Can you read what I just wrote? Perfect. Okay. So are these two the same equation? Let me highlight the two equations that we are testing, that we are comparing. These two equations, are they the same? What do you think? Okay, I have Jordan says yes. Jordan, I don't know if is that your answer. Is that your answer or not? Amina says no. They are not the same because there is a negative next to the y. Alex, that's correct. That is the reason why they are not the same. So, because they are not the same, the test failed. Okay, so there is no symmetry with respect to the x-axis. So I'm just going to put it simple here. No symmetry with respect to the x-axis. That's very clever. It has a higher probability for this equation to be a function. And what is that? Why now there's a higher probability of this equation being a function? Correct. And thank you for bringing that detail into the class. A function cannot never, how you say that? I don't know. And function cannot never be, or a function can never has symmetry with respect to the x-axis. because like Timothy says, then we will have at least two outputs for the same input, two y values for the same x value. And that is the rule of a function. A function says that we cannot have two outputs to the same input, two y values to the same x value. Okay? One plus one cannot equal 1 and 2, correct? All right. So that is for the x-axis. For testing with respect to the y-axis is exactly the same. The only thing that we are going to do is, instead of replacing y with its opposite value, we are going to replace x with its opposite value. So now we are going to focus on the variable x to test for the y-axis symmetry. So what I'm going to do is to take the original equation, y equals 16 minus, careful here, minus open parenthesis, minus x, closing parenthesis, and do not forget the power of 2. That power of 2 here is important. So we are going to simplify this. And you will notice that since we have a power of 2 here, and I should put this on red because I haven't changed anything there. Since we have a power of 2 here, and let me make sure that you are seeing this well. What will be the effect? What is the effect of that power over this negative here? What's gonna happen with the negative that we have in front of x when we apply the power of 2? It becomes positive. So we can just write, to simplify, we just can write x power, make it positive, yeah, Jordan, x raised to the power of 2. So that negative is not longer there. And then what we need to do is just to compare now our results with the original equation. And what do you think now? Do we have y-axis symmetry? Yes, we have y-axis symmetry. So I wouldn't use that for a function. I will continue saying we have a highest probability to this equation being a function. To test if a relation is a function or not, we are not going to talk about that in detail. There's other tests that will help us to determine if it's a function in the absolute of the truth of that statement. But I like what you're saying, Timothy, but keep with math, you want always to be very careful, not to be too absolute on just a few results. So I would change that to, we have now higher probability of this equation to be a function. With respect to the orange you said? No, that's okay. I like what you're saying. Is in math there are always going to be special cases, so that is always you want to be very careful with the conclusions. Okay, I like what you are doing. Okay, we have a higher chance of this equation being a function. That will be the safest conclusion at the moment, because we are not going to tackle the test for, we are not going to test if a relation is a function or not in this scenario. Okay. Good question. Good question. Okay. Since we don't know, since x is a variable, we are not allowed to apply the power of 2 to the x. The only thing that we can do is just to leave it there until we get a value for x. The square of x is just the square of x, because the value of the x variable is unknown. So we need to leave that expression as it is until we receive a value for the value of x. We could do that, but it won't be the simplified version. And when we are comparing two equations, we want to simplify both equations. That way it's going to be easier to compare them. Okay? If we put it in more difficult terms, it will be more confusing at the end to do the comparison. Did I answer your question about the power of 2 there? Okay, perfect. The last one is with respect to the O-ring. Remember, the O-ring means the mirror effect with the O-ring is that we have like two reflections, one with the x-axis and one with the y-axis. So what we are going to do is to replace y with its opposite value and also replace x with its opposite value. So we are going to be replacing both variables at the same time to test for the O-ring. So I'm gonna start with y because I have it on the left side. Then equals 16 minus, let me put the square here, and then I have here x, but I want to use its opposite value. And then what I want to do is to simplify. And there's not much here to do because we already done it. There's nothing surrounding. There's nothing surrounding the left side of the equation. We only have minus y, so we can drop those parentheses and we have just minus y. 16 minus, and we already talked about this, x squared. We are going to compare that result with our original equation, and based on our comparison, we are going to determine if there is any symmetry with respect to the O-ring or not. Careful with that. There are a special scenario, special graph that might surprise you. That's a good guess. That's a good guess, but you will find later that there are certain relations that might fail on one side, but then with the O-ring they pass. It is a weird scenario, and we are not going to talk about here because I don't want to complicate things. But the only thing that we can say is, one, we got to the final result of each test individually, then we are 100% sure that we know what type of symmetry we have, or is there no symmetry at all. Okay, so fail, no symmetry with respect to the O-ring. If you don't put this, and let me put it like here, this is the solution of, this is the final, what I'm putting on green, that is the answer. Is you This one, let's see. Let's explore why it is so. So we are talking about y equals 16 minus x squared. Okay, I don't know how well you are seeing this. Correct. The 16, once we got this point here, if we reflect this across the x axis and then to the y axis, then we are going to lose that symmetry. Okay. So always a good thing to do is you have a graphing calculator or you have access to the small graphing calculator, which you should have access because it's free. Go to the graphing calculator and explore its graph. And this is going to tell you more details about its symmetry. Okay? And we clearly can see that the effect of DAX16 moved the graph up from the vertex of the graph from 0, 0 to 0, 16. Okay? And thus transformation. And we're going to talk about transformation just in a moment. Okay. All right. So see that I didn't go to too much detail about this. I just showing you how you are going to solve it in the assessment. This should tell you what then is going to be important on the draft. Remember that I want you to edit the draft. I want you to work on the draft. I want you to make the draft your own, because that draft is the one that is going to help you on the assessment. The assessments are going to be open book and you want to use that draft. Okay, this is just a little bit of detail. I haven't covered everything here about the symmetry or all the cases. There are more cases here that I want you to explore. If you have questions about them, just let me know. Okay, remember that you are working with the review, that you need to complete the review entirely. So I expecting from you other questions, not now, maybe on the weekend. You can send them via email. It is important, your interaction and your participation in class. All right? Any question? All right. Next thing that we are going to do, if I can put this, let's see if I can create this, put this here. Okay. So in this exercise, let's focus on the graph first. I'm going to give you the graph. Then I want you to go and answer all of these questions or identify what each statement here is asking for. Okay? Determine the value of f of 0 based on the graph. What values give f of 0 equal if f of x equal to 0? Find the domain and range of f of x. Identify the intercepts. Say the interval in which the behavior of the graph is positive, constant, or negative. Find n extrema, the absolutes, and local max and minimum values, and take the interval in which the value of the function is positive or negative or 0. And that's, I choose those statements, but it's the same. Okay, so how are we going to do this? Again, I'm not going, this is kind of a review of lecture number 1. The first 20 pages talk more in detail about how to do this, or they talk more about what we are going to use here to identify those part of the function. Okay, but if you have questions, just let me know. Okay, again, I'm going to present you how to solve this exercise, how to answer these questions and that should tell you then what is important on the graph. Okay. All right. So the first thing that we are going to find is determine the value of f, the value of f of 0. Okay. F of 0 means that the x value is 0. The x value is given, is the input. The x value is 0. And what we are looking for is for the y value, the value of the function. This is our graph. This is the Cartesian plane. And we don't have numbers that guide us, but we know that the intersection between the two axes is the origin. So that point here has a coordinate of 0, 0. And that has a relation with f of 0, because f of 0 is saying that the input value is x equal to 0. So what would be, or what is the y value when x is equal to 0? And based on this graph, the y value is 0. Any question with that? Okay. What values? So let me put here. Here we are answering by the y value. We are looking for the y value. Now on B, what values give f of x equals 0? The y value here is 0. This question or this statement is asking for the x values. What are those x values that makes the function equal to 0? And that should tell you something also about the intercepts, because if the value of the function is 0, that means that the y value is 0, and in any point that the y value is 0, it is an x-intercept. So those values where f of x is equal 0, the value of the function is 0, are these points here. Okay? But the statement is not asking for the coordinate of the point, it's asking for the x value. So careful there. We are talking about the x value. So how are you going to answer that question properly, or that statement? This is how I want you to answer it. X equal to 0. Since we are talking about the same variable, we can just put a comma, and I will understand that it says x equal to 2.8, x equal to 3, and x equals to 5.3. Okay? Find the domain and range of f of x. So how are we going to find the domain? Domain is the collection of all the x values. Careful here. Don't confuse the coordinate notation with the interval notation. Okay? That's something that you need to be able to recognize when we are using interval notation and coordinate notation. Okay? Domain is the collection of all the x values. If we read the graph from left to right, we find a gap here. What is the meaning of that gap in terms of the domain? So let's first identify the location of this first portion of the graph, which goes from x equals 0, which is here, until x equal 2.8. So the interval, or the set of x values that represent this first gap here, or that first portion of the graph before the gap, is from 0 to 2.8. This is an interval. This is not a coordinate, what I just wrote here. So I am missing something here, I am missing something here. What I'm missing is a parenthesis or a square bracket. Square bracket or parenthesis. Which one is it? And how can we determine which one we are going to use? Any suggestion? It is including. If the circle is solid, if the circle is solid, then we are including those boundaries. Hence, when we are writing the interval, we use square bracket. Square bracket means that we are including. Then the gap, how do we represent the gap? The gap, we are going to represent it with a letter U of union. Okay? And then the other portion of the graph goes from 3 to 5.3. We are using solid dots there as well. So from 3 to 5.3. Let me erase this because I don't need this anymore. All right. For the range, we are going to do almost the same, but we are going to read the graph bottom up, and we are going just to answer based on the y values. I'm not going to put the range here. I'm going to leave that for you. If you have questions, let me know. But remember, this is just, I just presenting a few things, a few details. I want you to participate on question if you have questions. If not, we continue. Okay. D is find the intercept. And the intercept, when I say intercept, I'm going to be referring our class of the points. What are those points? So you are going to answer based on you're going to answer with a coordinate. Okay. What about range? How do we read? Okay. I am glad that you ask. Okay, so let's go and do the range. Thank you. That's the style that I want to do in our class. Okay, if I don't present something, ask your question, because then I will know what I need to teach you, right? So let's talk about the range. Let's focus on the range just in a moment. So for the range, we are going to read the graph from the bottom to the top. The part that is confusing, and sometimes is still confusing for me, is that, let me draw this a little bit better. Is that we need to, I don't know, I tilt my head sometimes sideways just to have a better read of what I'm looking for. Okay, so we need to focus only on the y values, and the y values of both portions start at 0. Okay, so from the bottom up, our left boundary in the interval for the range is 0. So I'm going to write it here, the range. We have 0. That is our left boundary. This is a solid dot. That means that we are going to include that left boundary. Then we go up, and there is no gap in the y-axis. So there's no need to close the parenthesis or the interval and use the U notation or the union notation. So we continue up until we reach the highest point in the graph. The highest point, it is in this line. So we have an infinite of points in that constant behavior of the graph. What is the value, the y value here? What is that the value of, or what is the right boundary in our range. Focus on these two coordinates. What is the y value here? It is 3. So our right boundary for the range is going to be 3. And also is going to be included because we have solid dot there, or we have a constant line there. Okay, so that is how we read the range. What is confusing sometimes is that we usually confuse, and that's a very common mistake, we confuse the x values with the y values. For some reason, I believe that reading the domain is easier, but the range sometimes causes confusion. Okay? Any question? Okay. Are you asking for exactly the names, domain and range, or are you asking why we use the x value for the domain and the y value for the range? I get your point. I know that the y value, since they are in the vertical axis, it looks like we are just talking about height or something like that. But range is the set of all the values of the functions, and x is the set. The domain is the set of all the inputs. So it's kind of difficult to put it in that way, in those terms that you spoke of. So exactly the name, why those names were chosen, I'm not 100% sure. Okay, but that's how we continue, and it makes sense when we start applying function in real life. In this sense, it's abstract. We don't know exactly of what those functions are representing. So sometimes making logic of the names when we are studying just algebra, the abstract part of math, it is difficult to connect the dots or connect what we have learned from real life with math. So I don't have like definitive answer there. But it is a good point that you brought to the class. Okay, so intercepts. So when we are looking for the intercept, we just need to put those points where we have intercepts. I'm not going to ask you identify x and y intercept. Just put all of them there, and I will understand. Okay, so 0, 0, 2.8, 0, 3, 0, 5.3, 0, so on. Okay. Find interval on which the function is positive. When we are looking for positive, is anything portion of the graph that is above the x-axis. Okay. Negative, anything below the x-axis. The representation of the positive value of the function are the regions of the graph that are above the x-axis. Okay. For negative, region of the graph that are below the x-axis. 0. What does that mean? Say the interval in which f is, let's skip negative and positive and negative for a moment, where f is 0. What does this mean? Why did I put 0 here? Okay, I think you are referring to the x-axis. I like that. I want to start like creating connection between how we can speak in math. B, ask us for what values of x of what values give f of x equal to 0. Is exactly the same question. State the interval on which f of x is 0. We are talking exactly about the same question, but different ways to ask it. All right. So what I want you to start like picking up is that in math, sometimes we are going to talk about the same thing, but we are going to change the wording, or we are going to change the way we express the same idea. Okay, and that's very important for our class. And what I want you to do is not to memorize; it's to start like thinking critically in math. Okay, to try to find the meaning behind what I'm going to present to you. Otherwise, math is going to be very difficult to apply in your real life career or in your real life in general. Okay. So yeah, that I don't like to present just math just for the academic stuff. I want to use math outside the academic stuff, and I want you to also do that as well. So thinking critically is going to help you to step a little bit more in your career using math. Okay, so E, how do we answer it? Well, positive, we don't have any negative value for the functions because we are seeing here the graph, there's nothing below the x-axis. So if you go and see that we are looking for the positive behavior, you are going to see that we are going to start from 0. Again, this question is about location. State the interval on which f of x is positive. Well, we are going to answer based on the x values because this question is about location. So from 0 to 2.8, I need to stop at 2.8 because of this gap. My question is, do I need to use parentheses or a square bracket in this case? This is an interval, and from 0, I'm going to erase all here to make it easier to read. So we are looking for the location of the graph. When I say location, the x values that give a positive value to the function. That is represented here in this region, because this graph is above, this part of the graph is above the x-axis. So here we have positive values. But I want to locate that. I want to point you on the Cartesian plane in where is the region with positive value for the function. So that is from 0, because this point is 0, 0, is from 0 to 2.8. Now, my question is, do I use square bracket or do I use parentheses? Okay. I like that you are relating the solid dots with the square bracket, and that's I like what you said. It is wrong though, but I like that you are starting like seeing details here. Let's explore about why it is wrong. It makes sense to use square bracket because there is a solid dot there. There is a point there. But what exactly is the value of the function on those points, and I'm going to zoom on those points. What exactly is the value on this point, in this point? What is the f of x value here? What is the y value here? It is 0. So because we are looking for the positive value, if we include 0 as part of the solution, then we are wrong, because we are including 0 as a positive value, and 0 is neither positive nor negative. So whenever we are working with behavior, careful, and I'm glad that you brought that into class, that you answered that way, because I prefer to answer wrong in class and not on the test. Okay, this is an opportunity to remember that, wait, I'm just looking for positive, not for 0, so I cannot include those boundaries. If I include those boundaries, I'm going to get it wrong, because I'm saying that 0 is positive, and that's incorrect. We are going to use U for union, because we have a gap. And again, go ahead. Yeah, let me finish here and go back to your question. I want this in red. From 3 to 5.3. Okay, I think you are asking for why did I use parentheses here as well. Is that your question? Okay. Okay. That's a great question. This is the point that we're talking about, where x is equal to 2.8 and y, the y value, is equal 0. That is the f of x value, or the value of the function, the f of x. We cannot include 2.8 as well, because if we include 2.8 as part of our solution, we are going to be wrong, because the y value at that exact point, the value of the function at that exact point, is 0. It is not positive. That is why we need to also answer or close this interval with a parenthesis. Perfect. Okay, so to answer, so we don't have negative value here, so we are not going to bother with that. To answer where it is 0, so I'm gonna write here because I'm running out of space. So I'm gonna screenshot, move these. Okay, now we need to find those values where the value of the function is 0. Okay, so we need to find the x values that make this happen. What are those x values? When we are talking, we are referring to a curve or a graph, we have an infinite amount of points. So that means that from this point to this point, the amount of points that we have is infinite. That is why we need to use interval. What happened with f of x? What are those values that makes f of x equal to 0? Well, we have only 4. We have one here, another one here, and the last one is here. So we have 4 values. That's a finite amount of points or numbers. So we don't need to use intervals, we need to use set notation. Okay, so we are going to use set notation in this case. How we are going to write set notations? Open with a curly bracket, and then we are going to separate each entry with a comma. So the first one is 0. Remember that we are talking about location, so we are going to refer only to the x values. 0, 2.8, 3, and 5.3. And we close with another curly bracket. And that is set notation. Why we are using set notation? Because we have only 4 numbers. We don't have an infinite amount of points. Any question? All right. What time it is? All right. So now let's find the string values. The string values are, when we are talking about string values, I'm referring to the absolute values and to the local values. Take a moment. Tell me on the chat or just speak up. No, write on the chat. Tell me what is the absolute value, what is the minimum value, the absolute minimum value, and also tell me what is the local maximum value and the local minimum value. Okay? I'm going to give you 2 minutes and put your answer on the chat. Yeah, Jordan. What I need is to put on the chat the absolute maximum value, the absolute minimum value, the local or the locals maximum values, and the local minimum values. You need to look at the graph that I'm presenting. You have that in the review, and just tell me on the chat those values. Jacqueline, go ahead. Okay, see, Jacqueline just told me her findings, and Jacqueline, me gustó que me pudiste identificarlo, lo identificaste como por punto, y eso es lo que vamos a trabajar ahora. Okay, I just tell Jacqueline that she identified the local, those values by the coordinate, by the points. The detail here will be that when I asking for the maximum values, I just referring to the y values. Okay? Ya que cuando estamos hablando de extrema, yo me voy a nos referimos solamente a los valores de y, de la función. Okay? So when we are referring to the extreme values, we are just going to answer based on the y values. Okay, let me give you an example. Let's find the absolute maximum value. Okay, so across this whole graph, which is representing the values of the function, we are going to find the highest point. Let's find just the highest point. Where is the highest point? And the highest point is all this, because we have a constant behavior here of the graph, and it is on the highest point. So the highest point gives us a y value of what? Of 3. So that is the absolute maximum value. The highest point, where is it? So the absolute maximum value, absolute max value is 3. Okay? Now, absolute minimum, the same concept, only let's find the lowest, the point at the lowest, or the lowest point. Yeah, let's find just the lowest point on the graph. And we have 4, right? But we don't care about if we have multiple points here. We just care about what is the value of those points that are in the the lowest points. The value or the y value at those points is the same, is 0. So the absolute minimum value is just 0. Now, that is for the absolute and maximum and minimum value, right? Let me put this here. Now, let's talk about the locals, because we could have a local maximum, or we could have no local maximum, or the same for the local minimum. All right. So now, when we are looking for local maximum, we are not going just only to select the highest point, right? We are going to find those peaks on the graph, okay? And we are seeing that this part here, it is a constant behavior of the graph. So the value here of the function is 2.8. It is not absolute because it's not higher than this region here. So now what we need to do, well, at least it could be a local maximum. We don't know yet. We need to go by the definition of local maximum. And the definition of local maximum is that then we are going to compare that point with a neighborhood around that point. So let's just take this region, that neighborhood here that I just highlighted. Can we find one greatest point or highest point in that region that I just highlighted? Is there a point in that region that I just highlighted that is the greatest of all, is above everyone there? If you are thinking no, then you are correct. So then there's no local maximum here, because we cannot surround a point in an open interval in this case and to tell, well, this is the maximum or the highest point in this neighborhood, right? So no local maximum. Now what about the local minimum? Let's focus on this one. We are not going to consider local extreme values on the endpoints. All the local extreme values are going to be in an open interval of the domain, or a region, a partition of the domain of the function. Okay, so the endpoints are going to be exclusively for the absolute value. We are not going to consider the endpoints when we are looking for the local extreme points. Okay, that's a interesting detail because it is confusing. But let's go to this graph just in a moment to then identify those absolute values and those local extreme values. Okay, let me help you here. So I just highlighted the absolute maximum. That point is above everyone else. I am highlighting the absolute minimum. That point is at the lower. It's the lowest point in our graph. Okay? In green, I'm going to present to you that local maximum. That is a local maximum. It's not the highest point, but if we surround that point in that neighborhood, that region of the graph, we can see that that point, it is the highest point. There is a local minimum, and also here there is a local minimum. Okay, with this graph it makes more sense. Okay, the difference between what is the definition or the meaning of absolute and versus local. Questions? Okay, I'm reading through your answers. Okay, careful, don't confuse the x coordinate with the value of the function. Remember, this is very important when we're looking for absolute and local maximum, minimum values. Just use the y values. Okay, the x values is going to give you only the location of those points. But in my class, I'm going to ask only for the values. So keep that in mind always. When we are looking for extreme values, y values only. Okay? Any question? All right. So I'm not going to answer the last statement here. Okay? That is going to be very similar to what we did on E, only you need to look for the increasing behavior from left to right. Is going to go up. The test, I don't know yet. It is going to look very similar to the review, but don't get scared. The review is on purpose huge and it will contain cases that are going to be more difficult than the cases that you are going to see on the test. Okay. But the format of the test is going to be very similar to the review. Okay. So a constant value, it is just a horizontal line, and I'm decreasing from left to right, it goes down, right? Okay, so I'm gonna continue moving. That's part of what you should have read for this class. If you didn't, please go and review first lecture. That's the first 20 pages, 1 to 19 or 1 to 20, depending. I don't exactly remember if we finished lecture number 1 in page number 19 or 20, but you will see when lecture number 2 starts. Okay, so I'm going now to jump to the draft. Okay, the first thing on lecture number 2 is what I just told a few minutes ago, or when we started class, is that the library of parent function, this is going to be a table that you are going to be referring back to it. You don't need to memorize this, but you need to know how to use it. Okay, so there's more reading material. I'm going to focus on the exercises, right? Transformation is something that I'm going to start presenting here on class. This is the first time that I'm introducing transformation here. We are going to have more chances to go back and to continue practicing, okay? Transformation is a little bit tricky. Once you get all the details and you understand everything, it's going to be very easy. But at first, it is tricky. It's like getting back to the definition and to the description. It will take a little bit of practice to get you there, okay? The first thing that we need to define when we're talking about transformations, okay? What are going to be those transformations? So we have here the parent functions, right? So we are going to create new functions based on these functions. And what we are going to do is just to transform the parent function into those new functions. That is the whole point of graphing techniques, transformations. We are going to take the library of parent function, and from then we are going to create new functions, new graph of functions. The transformation in a function will happen in two categories: vertical and horizontally. Okay. On those categories, there are different effect or different type of transformations. We are going to have shifts, we are going to have stretches, we are going to have compressions, we are going to have reflections. Okay, so those are the three types of transformation that we are going to have in two categories. The vertical category, that means everything that affects the y-axis or the y-coordinates of the function, and the horizontal category, that is when the x-coordinates are the ones that are going to be affected by the transformation. Because we have two categories, the first thing that we need to do, or we need to know, is to identify what is the output group of the function and what is the input group of the function. This is sometimes not so clear. Depending on the exercise, and it will take a little bit of practice to be confident on identifying the input group from the output group. All right? The input group is the argument of the function or anything that affects the input. Okay? Anything that happens inside the argument of the function that goes directly and affects the input of the function belongs to the input group. Everything else outside is the output group. the y coordinate. Okay, y coordinate, x coordinate. Keep that in mind because we are going to see how those effects apply to the coordinates of the values or point of the function. Okay. All right. Another table that is going to be important. This table, I make this table trying to simplify all the transformations into the two categories, into the three types of transformations, right? This is something that I want you to review. Reading through this exactly like this is not going to help too much. This is going to be a table that you are going to going back and reference to it. Okay, what I'm going to present are 3 exercises. Okay, and in those exercises I would go and explain the effect of the transformation on those particular exercises. Then what I want you to do is to go back to this table, read it, and try to connect what I'm just going to present with this table. Okay, so this is reading material, and this, remember, this is for you. This is your document. If you want to change the wording, if you want to completely erase this table and create a new one, you are welcome to do that. Whatever it fits you best in this class. Okay, so keep this in mind because here is where we have all the important information or the summarize of the transformation or the description of the transformation. But let's jump to the exercises. Also, I am presenting to you the transformation, the effect of the transformation in the graphs. Okay, this is more examples that you will go back and refer to them to see what are the effect of the transformation upon the graphs. So we have 3 exercises, and with these 3 exercises we are going to finish our class. Okay, I want you to see me how I'm going to solve this exercise because this is how I want you to solve them. Okay, the parent function x to the second power. Perfect. So on exercise number 1, so we are given this function. This is a function, okay? And the first thing that we want to do is to identify the parent function. This is where you are going back to the library of parent function, to that table, because you need to start identifying those key component on any function, and you need to start like putting together those key components with the library of parent function. So like Timothy said, the parent function here is x squared. It's a square function. Okay. Why it is important to identify the parent function? To then identify all the transformations that are happening. Well, because with the parent function, then we can identify what is different between the parent function and key of x. And in green, I am highlighting the 2 differences that we have between the parent function x, y equal x squared, and key of x. Okay, based on those differences, and here I'm going to, let me put this in this way so we can refer back to the document. This is what I want you to do. Let me go back to here. Give me a moment. Let me put everything in order. And I apologize if you cannot see well here or read well. If you have this document on your end or you have the hard copies, you will have the print out. You can follow what I'm going to do here. Okay. On the left side, I have the exercise. On the right side, I have the table of library of parent functions. So in the library of parent function, whenever you are given a function, you are going to the library of function and you are going to identify where is the parent function of the function given in the exercise. So we have identified the square function here. So now we know that q of x is based on the parent function on a square function. Okay? So that is what you are going to do to identify the parent function on the equation. The other thing that I want you to do is with the transformations, we have this table here, okay, on the right side. You are going to follow this table to then describe any difference between the function that is given in the exercise and the parent function, okay? Okay, let me grab my pencil here and okay, you said transformation number 1. Let's identify. Before going that, let's identify if are these transformation in the output or the input. Look, you're almost there. You're almost there. It's going to be compression. It's going to be a particular compression. How are we going to identify between the input group and the output group? Okay, the input group is anything that happened to the x, right? How are we going to identify that? Let me give you an example of 1/2 affecting the input group, not the output group. Here is the output. This +1 is also affecting the output group. That's part of the output group. If the input group, if 1/2 would have been affecting the input group, we are going to see it this way. So a parenthesis will enclose 1/2 times x, and then the square, the power of 2, is going to apply to the entire x, 1/2 x. Okay? This here is affecting the input. Okay? Careful with this. This is the part that is tricky. Identify, well, is this output or input? Look always for the parentheses. The parentheses are going to tell you. Is there a parenthesis there? It's because they have a reason to be there. Okay? And we use the parentheses to separate the input group to the output group. Okay? Now, that 1/2 is in the output group, and you will see here that it is advised to follow the order operation to identify the transformation. So I like to follow the order operation because that guides me through the input group, from the input group to the output. There's nothing in the input group here, so I'm going to focus on the output group. And before addition, I'm going to analyze multiplication. So we have 1/2 times x squared. That is a vertical compression by a factor of 1/2. Okay? And that is because of this 1/2 in front of x squared. The other one is going to be a transformation. That transformation is going to be also vertical. It's going to be up. That is going to be a shift. Let me put it. Shift upward one unit. pay attention to the vocabulary here. When we are multiplying, we're talking about factors. When we are adding or subtracting, we're talking about units. Okay? So these two transformations are vertical, meaning that they are going to affect the y coordinate. Okay? So the x coordinate are not going to change. They are not going to be affected. Okay? This is important because we now know that what we are going to do is to change the y coordinates. But from where we are going to get the y coordinates? What point are we going to use? Is there any reason of having key points for the parent function? The answer is yes. In order to graph q of x, and because we are going to graph it using as reference its parent function x squared, or the square function, the key points are going to be important for us. Because we know that from the table of the Laredo parent function, we have 3 key points for the square function. The key points are those points that will help us to trace the curve or the shape of that function. So I know that the key points of y equal x squared are -1, 1, are 0, 0, and also are 1 and 1. Key points of, yeah, the visually a vertical compression, it will also look as a horizontal stretch, but they are not the same. Okay, so we know that we have 2 vertical transformations, no horizontal transformations. So from the key points, we are going to get the key point of q of x. All right? We can evaluate the value of q of x, but we are not doing that here. We are graphing q of x based on its parent function. We are going to use its parent function as a reference. So here are the key points. Okay. So since there's no horizontal transformations, the x coordinates are not going to change, because what I'm going to produce here, what I'm going to identify now, are going to be the key point for q of x. So there are 3 key points that are important for q of x. Now, the y coordinate is the one that is going to be affected by the transformation. And we know that we have a vertical compression by a factor of 1/2, and we need to shift upward the graph 1 unit. So we can create an equation that will help us to identify or to evaluate the y value after the transformations. A factor by 1/2 means that we are going to multiply all the y coordinates by 1/2. Upward 1 unit means that we are going to add all the y coordinates by 1, and we follow the Euler operation, 1/2 times y plus 1. So we are going to use this equation here, that equation is the one that we are going to use to take these y values and to get the new y values for the q of x. Okay, so what I'm going to do is to plug in these y values. for example, I have 1, y equal 1. So 1/2 times 1 plus 1, that will give me 1/2 times 1 is 1/2 plus 1, that is going to be 3/2. Okay, so that's for the first point. So here I have 3/2, positive 3/2. Okay, then I have y equals 0 here. So 1/2 times 0 plus 1. So this is just 0. This is equal to 1. So this is my second point, 0, 1. Okay. And then I have 1 again. So it will be 1/2 times 1 plus 1. Again, it's going to be 3/2. Okay. So these are my points. And these are key points for cube of x. Key points are going to help me to trace the curve of cube of x. So in the review, we have this Cartesian plane. That is going to help you to plot the points. But there's no grid, so you need to define how it's going to be your grid. So I'm going to define this 1/2, 1, and 3/2. Why? Because I have 3/2 here. Okay. So I know this is 1. This is -1. This is -1 here. And there. So then you are going to plot those points. So -1, 3/2, it is here. So we have this point. 0, 1, it is here. So we have this point. And then we have, this one is, sorry, that was incorrect. That should supposed to be positive 1. Positive 1. Remember that the x coordinates are not affected. Okay. And then 1 and 3/2. This one. 1 and 3/2. So those are those points. So 1, -1, 3/2, 0, 1, and 1 and 3/2. So I know that it is a square function. It is a parabola. So the only I need to do is just to have those 3 points. It doesn't have to be perfect. This is just a representation. I'm not an artist, so it's very difficult for me to draw a parabola. But this is going to be good enough for me. Okay. So we are 5 minutes before 11:50. I don't want to rush any exercise. I don't want to rush any example. So on next class, I'm going to discuss exercise number 2 and exercise number 3, and then we are going to proceed to piece y defined function. Okay. So next Monday, I believe I'm going to finish the 3 lectures. Okay. Sorry, it is rushed. It is a fast pace. It is summer, but that's why I made the calendar this way. Okay, so we can have more practice rather than a fast-paced math class. Okay, so prepare for next week, because I hope that I can finish all the theoretical part of the first test and start practicing since next Wednesday. Since Wednesday. Okay, this is. It's a continuation. We need to continue with piece y defined function. We are going to do it. But my main goal right now is to start practicing since next Wednesday and start working with the project. Okay? Any question before we finish our class?